Assalamualaikum and a very good day to you all. In this video, I would like to share with you about second order partial differentiation test, or simply SOPDIP. Okay, so this acronym thing, I made it up myself. I don't think it will be in the books or whatever, but for the sake of easy reference, okay, so I will use SOPDIP from now on. Yeah, so since we had the critical points for f, x, y, this is you have to watch the video about critical point first, then you will understand what this test is about. Okay, so since we have the critical points, okay, so it is a must for us to use a certain test, okay, to test our critical points, because we want to know the purpose of getting critical points is for us to decide, or maybe to also process, to distinguish, okay, to discriminate, okay, which one is maximum or which one is a maximum for us to apply in our daily life. Okay, for example, in our industry, okay, we have to find differentiation. We have to do this kind of test to find maybe maximum the quantity of x that ensure a maximum profit or something like that. Okay, so the formula is given by D, it's a capital D, DAB equals F sub XX AB multiply F sub YY AB minus F sub XY AB squared. Okay, now this is the formula lah. You can look into the book also, the same thing. Okay, so what's interesting about this formula or this test is that unlike first derivative test and second derivative test, okay, in partial differentiation, our critical point can be either a maximum, okay, a minimum, or a saddle point. Okay, what does it mean by saddle point? Saddle point refers to the shape of the surface that we get. Okay, so the point that saddle means saddle is a seat for a horse. If you want to ride a horse, then you need to sit on something, and that something is called saddle. Okay, tak apa, I will show you what how the shape is, but we go through this process first. Yeah, okay, so I've made a flow chart, okay, I suppose, to smooth our process of determine whether it's a saddle, a maximum, a minimum point. Okay, so what is this flowchart about? It's about, okay, so probably is the name itself. Okay, so we start over here. We start with the G. Oh, wrong. I made a mistake. Not G, D. Okay, done. Settle. Back lah. Why didn't some more? Okay, good. Now, so from the formula DAB, AB means we get the value of critical point, and then we substitute inside the formula. Okay, so if the value is less than 0, then AB is a saddle point. Okay, so what happens if the value of DAB is greater than 0? Next, we have to look at the value of FXX that we substitute with the value of critical point lah. Okay, if the value of F sub XX is less than 0, then AB is a maximum point. While if it's greater than 0, the value of F sub XX AB is greater than 0, AB is a minimum point. Now, what happens if we get exactly 0, like this? It means that the test fails. So, simply put, we cannot decide whether the point that we test with the formula is maximum, minimum, or saddle point. Okay, so let's do one or two example. How many example? 1, 2, 3. Okay, 3. Tak apa. Let's see. We do the first one. Okay, so find all possible. As usual lah, we find f sub x first. So 4x plus 2y plus 0 minus 2 minus 0 plus 0. Okay, and then we tidy it up. Minus 2 over here. Okay, and then we find f sub y. Okay, 0 plus 2x plus 2y minus 0 minus 2 plus 0. And then I tidy this up. Okay, and then we get this one. Okay, move it over there. Perfect. Now, remember, we want to find the critical points and determine their nature. So, how to find critical point? Critical point. Okay, so we let sub x, f sub x equals 0, f sub y equals 0. So we have 0 equals 4x plus 2y minus 2. And 2x plus 2y minus 2. Okay. And then I think can simplify like this one. 2x 2x plus y minus 1. So y equals 1 minus 2x. This one also can simplify, x plus y also. X plus y minus 1. So y equals 1 minus x. Okay, so this one can put there. So we get 1 minus x. Okay, equals 1 minus 2x. Okay, so minus x plus 2x. 1 minus 1. So we have minus x 0. 0 lah ni. X is 0. Okay, and then y equals 1 minus 0. It's 1. Okay, so therefore critical point is 0, 1. Okay, now we want to test this point to get whether it's a maximum, minimum, or saddle point. So we might need f sub xx, sub yy, and sub xy. So it's convenient for me to copy that one first. Easy to refer, because if you kept scrolling then you confused. So this one we get f x sub xx is 4 lah. 4. Okay, and then y what's this? 2 lah. Yes. And then f sub xy it's 2. Okay, so let's get the xy equals fxx is 4, fyy is 2. Why my bracket is too many? 2 minus fxy squared. Okay, so we have 8 minus 4, which is 4. So remember, 4 is the value of dx. If the value of big D is greater than 0, we need to look this one, if it's greater than 0. Okay, if it's greater than 0, we have to look at the fxx b. Okay, so we need to look at f sub xx. Okay, look at sub xx. So copy f sub xx equals 2, which is greater than 0. Therefore, minimum. So since D, what is the point? 0, 1. Okay, 0, 1 greater than 0, and f sub xx 0, 1 is greater than 0. Okay, therefore 0, 1 is a minimum point. Okay, so I think this video is now 10 minutes already, so I might continue with the other 2 example with a new video. Thank you for your time and attention for now. Assalamualaikum. Have a good day.